Okay, so good morning, everyone. I'm Izza, and on behalf of our team, allow me to present UPass. So UPass, which stands for University Portals Augmented with Smart System, is a project under UP and is led by Dr. Atienza and Dr. Randley Cojote with the aim of improving the security of our university. Specifically, it aims to improve the sticker system currently being implemented by UP. Now, while the sticker system is a widely used or a system to regulate vehicles entering certain premises, it does have its own disadvantages in a sense that one, manual inspection of these stickers is potentially or can potentially slow down traffic and is relatively time consuming. So as you can see in this image here, you can imagine a guard stopping an incoming vehicle, or let's say incoming vehicles, in order to check one by one if those vehicles have a sticker. So, and actually to further elaborate my point, allow me to briefly narrate an experience, no, wherein the gate closest to EEEI, which is the same gate that where our system is currently being deployed, is the Velasquez gate. So kung nakadaan na po kayo doon, and the guards monitoring that gate used to be very strict in a sense that if wala po kayong UP sticker, you will not be allowed to enter. Despite this, some drivers still try to negotiate with the guards that maybe with just their UP ID, they could be allowed entry. However, despite that, of course, the guard still says no. And to be fair, we really cannot blame those guards because they're just doing their job. But at the same time, we also understand the concern of the students, the UP staff, especially those whose workplace is just near the Velasquez gate. But because of this, will be or were greatly inconvenienced. Moreover, that negotiation between the driver and the guards is more often than not what causes the traffic dun po sa Velasquez Gate. So here's where UPass comes in. Wherein, as part of the team, we try to alleviate some of those concerns or those issues by assisting, not replacing our guards in order to improve their overall efficiency and therefore the overall security of UP. And shown here is our current setup, dun po again sa Velasquez Gate, wherein on the left side, you can see our data cabinet being installed. Yung black po na nasa likod. And on the lower left of that same image is yung camera po namin, which is the same camera na makikita niyo po dun sa right. And on that right image is also our monitor, which displays the current plate predictions based on the vehicles na nakikita po nung camera. And shown here is our full system diagram, wherein we first capture images of vehicles through the camera, and those images are being passed on to the Jetson or Nano, which is an edge device developed by NVIDIA capable of hosting as well as running AI models. And yung predictions po doon will be passed to the monitor, the same monitor I showed earlier, as well as an in-house server where all our data are currently stored. And that data can be accessed by our web app. Now, the web app is still under development, but its main purpose is to act as an interface for an admin to track down data records, yung mga records po na nasa database, but can also be used for demo purposes, and only then will it be viewable by the public. Now, I mentioned AI models earlier, and since this is an AI talk, what models did we use then to build our system? To answer my own question, we actually used two state-of-the-art models, the YOLO V8X, for both vehicle and plate detection, as well as Parsec, which is actually a network that was developed by one of Dr. Atienza's grad students, Sir Darwin Bautista. And shown here is our model diagram naman po. So given an image, the YOLO V8 predicts two sets of bounding box coordinates, one for the vehicle and one for the plate. So yung TLX, TLY, BRX, BRY po doon corresponds to the top left and bottom right XY coordinates of those bounding boxes. And from there, we extract the plate area from the image using the given plate box coordinates po ng YOLO. And then that extracted plate will then be passed on to Parsec, which then predicts the corresponding plate text naman. And the lower left, you can see our sample output. Now, these models are already pre-trained by the proponents working on YOLO V8 and Parsec. However, they were trained using data sets that aren't fit for our task. So with that, we'd need to have or to look for publicly available data sets with enough data points for our task naman. And that is because neural models generally require extensive amounts of data for training in order to predict accurately. So we did just that. We found multiple data sets for vehicle detection as well as some for plate detection. Specifically, the Kitty data set, as well as the CCPD or the Chinese city parking data set for vehicle and plate detection respectively. However, we did encounter some challenges with these public data sets. Specifically for vehicle detection, the annotated vehicles do not include some of our local vehicles like the jeepneys, the tricycles. And this is because those data sets are usually, or most of those data sets are usually created by universities or organizations from Western countries. So as you can see here on the top left, it mostly shows yung mga private vehicles po, cars, sedans. They do have some buses and trucks, but of course, no jeepneys and no tricycles. Kasi yung data set po nila only consists of vehicles commonly seen in Western countries. And for the plate naman, of course, the license plate do not follow the Philippine standard format. In our example here, it follows China's standard registration plate format because it's a Chinese data set. So if we only build a system based off of models that are only trained with this public data set, naturally our system would actually produce relatively poor results or bad performance. And because of that, the team decided that we should create our own data set. And we actually did, or actually are currently also still trying to expand our data set. And shown here are just some samples of our some vehicles in our data set. So we include both commonly annotated vehicles, like the private cars, motorcycles, and bicycles, and we also include local vehicles like our PUVs, like the jeepneys, the tricycles, and actually electric vehicles like the e-bikes and the e-trikes. And we annotate both the vehicle and their license plates if available. So how did we do it? To create our data set, we used a semi-automated labeling strategy to speed up the annotation process. So how this works is that we first manually annotate a set of images, and then we use that set to fine-tune our model, which we then use to generate initial predictions or initial annotations, which the annotators will then just refine. It's just a rinse and repeat process wherein the refined annotations are then used to fine-tune the model, to generate annotations naman of another set of data set, and so on and so forth. And the good thing about this is that with repeated training or further fine-tuning, we would be able to, our model gets more and more accurate and will produce better and better annotations, and hopefully later will translate to the lesser need for to refine the annotations. So hopefully in the near future, we'll be able to transition to a fully automated labeling strategy. Now, okay, so we do admit that due to the sensitivity of our data and the concerns of privacy, the team noted early on that we should look for a tool that's can be deployed locally, but at the same time can be accessed by multiple annotators. That doesn't require them to be in the lab, for an example. And fortunately for us, we're able to find such a tool, which is the computer vision annotation tool, which is a full support for local deployment and self-hosting. So hindi po kami sponsored, no? Pero we just like to share it to everyone in case there are others here who are facing the same concerns as us. And shown here is our final, the current system results. So from an accuracy of 10.2, we were able to improve it to 61.9% after repeated fine-tuning. And by the way, the accuracy, we define accuracy here as whether or not our system was able to detect the vehicles and also give correct plate text predictions versus the ground truth. And for vehicles that do not have license plates, such as the bicycles, the system must still be able to detect them, but at the same time, just give a plate prediction of none. And below are our model-specific results, where we achieve an F1 score of 96.1 for the vehicle, which is already relatively high, a 77.1% for plate prediction to an overall 86.9 F1 score for YOLO V8X, as well as an accuracy of 86.5 for plate recognition from Parsec. So as you notice, the F1 score of our plate detection is actually relatively lower compared to other scores, and this is likely due to the low recall scores, which can be attributed to actually just a few instances of our plate bounding boxes compared to the vehicle. And actually, currently, we're thinking that these scores is what's causing the bottleneck in our system accuracy. So currently, we're still in the process of further annotating more, or annotating more data in order to improve our system results. And shown here is just a brief demo how to play, showcasing the current capabilities of our system.
Thank you for the presentation. So may I ask, what is the size of the data set that you use for UPass?
Okay, so Okay, I'll answer the question first. So currently, we actually have 2 days worth of data, which is about 26,000 images, and we use that to train our, actually 28%, around 8 or 10% of that, so 2,000 is used for validation, and around 26 is used for training. So we use it to train both the detection models as well as the plate text predictions.
Thank you, thank you.
Okay, so as you can see, it was able to detect the vehicle, a private vehicle, and I think the next was a jeep. Meron po kaming live demo sa labas, if in case. But that's all. Thank you very much for listening. Then that was UPass.
Very good. So now you can go to UP and you don't need to. Can you still ask the guard? I mean, the guard would still ask the drivers.
UPass is still not fully implemented, so it's still in the experimental phase. But maybe in the future, who knows? Okay, so just to answer his question, which was if the guards would still need to ask the drivers. So currently, UPass is still not fully implemented. It's still in experimental phase. As you can see, yung accuracy po namin nasa 60% pa lang. But maybe in the future, depende po.
Very good. So hopefully in the future, so we can enter UP smoothly. So to give you the certificate of appreciation to Ms. Izza Jalandoni for sharing her valuable insight and work on UPass University portals augmented with smart systems. During the NEECECON 2024, given this day, 19th of July 2024 at Novotel QC. So signed by Dr. Liu Tria, Director of UP EEEI.